For part C and D of my question, I've been asked to work with unknown mean and unknown sigma. So as soon as I know that's the case, the way I've taught this to you guys is to actually draw 3 diagrams. I think this is the best option. So 3 diagrams on the left-hand side, and then 3 diagrams on the right-hand side. This is my preference. The top ones are going to be x is normally distributed with your unknown mean and unknown sigma. And the bottom 2 are standardized to 0 and 1 squared. So that's 0, 1 squared. And this one is normally distributed 0 and 1 squared, normally distributed 0 and 1 squared. And then if you put the means in, and this one is the unknown mean, now I'm going to try and answer the question. All of these are normal distributions. And all I'm going to try and do is fill in information and then try and set up simultaneous equations. So for the first one, the key part of the question is that 20% of calls take more than 17 minutes. So this information I want to try and represent on my diagram. Before I do that, let me try and write this as an inequality. And if you're not sure how to do this, you know that you're always going to have probability x equal to something. And the equal to something is normally a percentage. So let's just put that in as 0.2. So I've done most of the question already. And now it's just common sense. Take more than, so that's greater than 17 minutes. So if you put in the percentage first, I think it makes it much easier. So for this second statement, 10% of calls take less than 8 minutes. I would use the same strategy. You know it's going to be something like this. X equals to 10%. 10% is 0.1. So put that in first. And then just use common sense. Less than and 8. So you can really handle this part of the question with finesse if you use that strategy. And now the next part is to actually represent these on my diagram. So x is greater than 17. Greater than means I'm going to start shading from the right. And 0.2 means I stay on the right hand side. And that's representing my 0.2. 17's here, x equals 17. I can write that here for you to make it more obvious. For the right hand diagram, x is less than 8. Less than means I start shading from the left. So less than, you start shading from the left. And this is now going to be representing 0.1, an area of 0.1. And here, my x is equal to 8. So I think that's probably the hardest part of the question. Once you've deciphered what this means, written them as inequalities, and then put it onto your diagram, we're sort of, going towards the right steps. And now, these diagrams are representing the same question. Okay, so they're proportional. So that's 0.2, that area is 0.2, that's 0.2. Here, this one is 0.1, and this one is also 0.1. But the reason why I'm using these standard normal distributions is because I want to standardize now. I want to standardize my x values. So just to remind everyone, for standardizing, we use z is equal to x minus mu over sigma. And this is how we standardize so that you end up with a normal distribution, a standard normal distribution with mean of 0 and sigma of 1. So let's do that. I've got z here is equal to 17 minus mu over sigma. In this question, I'll have whatever the z value is, it's going to be 8 minus mu over sigma. I can actually work out what those z values are, which is why I've got my third diagrams. And that's using your calculator's inverse normal, and the area for this will be the area from left up until that point. So the left-hand side up until that point, and I'm just going to shade that in blue. This area is 0.2, 1. The whole area is represented by 1. 1 minus 0.2 is the area of 0.8. So let's type that in our calculators. The mu here is 0 and the sigma is 1. So if I type that in, so menu 7, inverse normal is 3, your area is 0.8, sigma is 1 and mu is 0, you get an answer for the z value of 0.84 to 4dp. So I've done that one. Let's deal with this one. This one's much easier because it's already on the left-hand side. So, and again, inverse normal, your area from left up until that point is 0.1. Mu again is 0 and the sigma is 1. So if I do that again, 0.1 is 1 for sigma and 0 for mean, and you end up with an answer of z is equal to minus 1.2816 to 4dp. And now you're in a situation where for both statements you can form equations. So I have in these graphs 17 minus mu over sigma is equal to 0.8416. On the right hand side we've got 8 minus mu over sigma is equal to minus 1.2816. So I have two equations and two unknowns. So let's solve it. 17 minus mu is equal to 0.8416 sigma. 8 minus mu is equal to minus 1.2816 sigma. And now I'm going to try and bring everything together. And I'm going to take advantage of my calculator and try and solve this using the simultaneous functions on my calculator. So 0.8416 sigma, that's that one, plus mu, that one, is equal to 17. Here, I'll have minus 1.2816 sigma, that term, plus mu, which is this term, is equal to 8. Just going to double check I've done that correctly. I believe I have. So this is now equation 1, and this is here equation 2. And what I'm going to do is I'm going to rewrite this just so that we don't make any mistakes in the form in which I put it into the calculator, which is 0.8416x plus 1y is equal to 17. And here I have minus 1.2816x plus 1y is equal to 8. It doesn't matter what you put in for x and y as long as you're consistent. And now I'm going to say, let's use our calculator menu, go down and select equation function, simultaneous equations, number of unknowns is 2. And for my x coefficient, I'm going to put in 0.8416 and my y is just 1, which is easy, and then 17. So the coefficient of y is just 1. The next equation is minus 1.2816. The coefficient on the y is 1, and that's equal to 8. If I press equals, I get my answer for x. My answer for x is 4.23888, and carries on. My answer for y is equal to 13.43255. So it's very important that you're consistent, because I know that my x in the calculator is representing sigma. So sigma is equal to 4.2389 to 4dp, and my mu, which is the mean, 13.4326. And now I've been able to work out what the mean is and what the standard deviation is. To answer part D, state whether or not the calculations in part C support the supervisor's claim. The supervisor's claim was that the mean call time is less than 16 minutes. And as you can see, that my mean call time from part C is 13.4326, which is less than 16 minutes. Therefore, my answer is consistent with the supervisor's claim. My advice is, when you do these questions, really break down every step. There are students who can do these questions just by forming the equations without these diagrams, but my advice is draw the diagrams. If you don't want to draw 3, at least draw these 2. It will really help you clarify your thinking and make sure you don't make any silly mistakes.